Hi, this is Mrs. Sigmund. We're going to look at section 3.3, linearity and continuity of graphs. And again, we're still in unit 2. So this section starts off with talking about labeling graphs, whether they are discrete, continuous, or neither. And we can tell based on the information that's on the graph. So in this first one, we notice that there are dots kind of all separated. That makes it discrete. In this middle one, if I were to trace it, it's a consistent tracing with no pickup of my pen. So that one is continuous. And then over here, we have neither. There are parts that are connected, but then there are also parts that are separate. So that would fall under the neither. We're also going to talk about what makes something linear versus nonlinear. So if it's linear, it's going to make a line. Things are going to constantly change in the same way. Equations, we want to be able to write in the form ax plus by equals c, where a, b, and c will be integers, meaning not fractions, and then x and y will stay letters in our equation. If we can't write it out like that, then it's what we would say is not linear, or things don't form a straight line. And if we look at kind of the pattern on maybe a table, they wouldn't be changing in the same way. So let's look at an example of an equation asking if it's linear or nonlinear. Again, we're trying to get it in the form of ax plus by equals c. So to start, I need to move my terms so that they're on the same side. I'm going to add 2y to both sides because that will make my x stay positive. That gives me 8 equals x plus 2y. That's basically the same thing, only I have my c in the front instead of at the end, and that's okay. All of those are integers. There's no fractions. Right here we have a 1. So this one is linear. In my values for a, b, and c, well, a is always going to be paired with the x. So my a is 1. B is always paired with the y, in this case 2. And then c is the number that we would have by itself, no variables, and on the other side of the equation, in this case, an 8. So here are some more examples. If you want to pause the video and try these on your own, you can. And then I'm going to go through them here in just a moment. So this one, I need to do some work. We want to get rid of those parentheses. And again, when you see those, I'm hoping your brain jumps to distributive property. So we're going to distribute first. That gives me 8x minus 4xy equals 9. There's no way for me to combine like terms so that I have just x's in one term and just y's in the other. So this is going to be nonlinear. Moving across, I'm going to move my x over to the other side. That way I have x's and y's on one side and y's or constants on the other. That gives me 2x minus 3y equals 5. X and y are together, constant is on the other side, and there are no fractions. This one is linear. If I had to label my a, b, and c, it would be 2, -3, and 5. Here we have another equation that has fractions. So for starters, I'm going to move this 3/4 over to the other side by subtracting. That'll give me -3/4 x plus y equals -1/3. And then to get rid of my fractions, I'm going to multiply by that least common multiple. Well, 4 and 3 both go into 12. And I'm going to try to get rid of that negative, so I'm going to multiply by -12. -12 times -3 is positive 36. Divided by 4 gives me a 9x. Then -12 times y is minus 12y. -12 times -1 is positive 12. Divided by 3 equals 4. So I am able to write that in the form that I need. This one is linear. Lastly, I have this going on in my example. We will not have any exponents on any variables in a linear equation. So that's my big giveaway, that this one is nonlinear. Okay. In a table, we're looking at the pattern. So how have the x's moved and how have the y's moved? We want to pay attention to the distance between. So from here to here, it moves up 1. From -1 to 0, it moves up 1. 0 to 1, it moves up 1. So really, when we look over here at the y's, we can kind of compare all of them. Some of your tables will not move in such a pattern. Here, we go from 4 to 1. So we dropped, so I'm going to make that -3. From 1 to 0, we dropped 1. Well, that's not consistent. So right away, I know that this one is nonlinear. Looking at table B, from -2 to 1, I move up 3. From 1 to 2, I move up 1. That does not mean that it's nonlinear. It just means that those wouldn't be two rows that I would compare. 2 to 5 moves up 3, and then 5 to 7 moves up 2. So I maybe want to look at this jump, and I want to look at this jump, and I hope that they move in the same pattern. From 8 to a -1, we've moved down 9. From a -4 to a -13, we've moved down 9. So that follows the same pattern in the y's changing that it did in the x's. So this one is linear. Here we have a word problem. It's basically the same thing. We're going to kind of focus in on the table. It's just that the table tells us some information about a scenario. So again, we're looking at our x's. Here we go up 1. Here we go up 2. Here we go up 1. Here we go up 3. Then 1 and 1. So we have lots of options of things that we can compare, but setting it up that way is going to help. This one is actually a multiple choice problem. I guess I should shift that down a little bit. I'll just move this information to the smaller table. Okay. So it may help to kind of look at the pattern that we have. When we jumped by 1 from 2 to 3, our distance went up 43 miles. And then my next jump of 1 hour also went up 43 miles. When I look at 9 and 10, that moves up by 1, but this one moved up 0 miles. So I have some inconsistencies. Off the bat, I'm going to say that this is non-linear. So when I look at these choices, I can see linear and nonlinear. I'm going to cross out A and C because those ones say it's linear, and I just decided that's not the case. So then we're going to look at our reasoning. Here we have, because she travels 43 miles between 2 and 3 hours, and only 0 miles between 9 and 10 hours. And so that's what we just found in the table. So that finishes that lesson. And there's an assignment on Reveal, section 3.3, for linearity and continuity. And all of your PDFs of those are attached to the assignments.